Okay, so good day to all of you. So this is the last chapter for the systems analysis and design. So which is chapter 12, managing system support and security. So this is something to do with the final phase of the systems development life cycle. So for the phase description, systems operation, support, and security is the final phase in the systems development life cycle. You will support and maintain the system, handle security issues, protect the integrity of the system and its data, and be alert to any signs of obsolescence. The deliverable for this phase is an operational system that is properly maintained, supported, and secured. So the following are the chapter objectives. Explain the system support and security phase. Describe user support activities, including user training and help desks. Define the four types of maintenance. Explain various techniques for managing systems maintenance and support. Describe techniques for measuring, managing, and planning system performance. Explain risk management concepts. And assess system security at 6 levels: physical security, network security, application security, file security, user security, and procedural security. Aside from that, we have to describe backup and disaster recovery, list factors indicating that a system has reached the end of its useful life, assess future challenges and opportunities for IT professionals, develop a strategic plan for career advancement and strong IT credentials. So for the introduction for this chapter, managing systems support and security involves three main concerns. We have the user expectations, the system performance, and security requirements. Successful robust systems, so mostly these are the mission critical systems, often need the most support. And then in most organizations, more than half of all IT department effort goes into supporting existing systems. So for the overview, the system support and security phase begins when a system becomes operational and continues until the system reaches the end of its useful life. After delivering the system, the IT team focuses on support and maintenance tasks. So first is we have the user support. So since the information system is already operational, you should have a system, or rather a user support for your end users. So first method for user support is the user training. So additionally, new employees must be trained on the company's information systems. You should not expect that all of your employees know how to use the system, especially if it is new. So you have to assume that they don't know anything and they need training. So we have different user training package. So training users about system changes is similar to initial training. If you already upgraded your information system, of course you also have to train for the new features of the information system. The objective is to show users how the system can help them perform their jobs. Okay, another type of user support is the help desks. So it enhances productivity and improve utilization of a company's information resources. So the help desk is a central contact point for all IT maintenance activities. It can utilize many types of automated support. So for help desks, we have these outsourcing issues. So offshore call centers can trim expenses and free up valuable human resources for product development. So that's why help desks, some are being outsourced in other countries. For example, a company in the US or in UK, and then their help desks are located, for example, in the third world countries or in Asia, for example, in the Philippines. So that's why, for example, if the call center agency holds a British account, so their customer representative must learn British language so that it can mask that, oh, the customers from the UK can mask that, they cannot really predict that, oh, the call center agent is from the Philippines. So that's why for call center agents here in the Philippines, they are learning the language based on the account that they are holding. So critical factors might include phone wait times, support staff performance, and online support tools. Okay, next is we have the maintenance task. Actually, we have five maintenance tasks. We have corrective maintenance, adaptive maintenance for minor enhancements, and another adaptive maintenance for major enhancements. We have perfective maintenance and preventive maintenance. So how is it done? So there are, for example, for immediately after implementation, early operational life, middle operational life, and later operational life. So in immediately after implementation, so both perfective maintenance and preventive maintenance is low. Corrective maintenance is high because, of course, for immediately after implementation of the system, if there are errors, so corrective maintenance must be done. And then adaptive maintenance is not done immediately after implementation. So for early operational life, so corrective maintenance is low, and then adaptive maintenance for major enhancement, it is not done in or early operational life. Then adaptive maintenance for minor enhancements and preventive maintenance are both medium. And then perfective maintenance is low to medium. And then for the middle operational life of the information systems, corrective maintenance is low, while adaptive maintenance for minor enhancements, perfective and preventive maintenance are medium, and then adaptive maintenance for major enhancement is medium to high. And then last, for the later operational life of the information system, so perfective and preventive maintenance are low, then adaptive maintenance for minor enhancement is medium, then adaptive maintenance for major enhancement is medium to high, and corrective maintenance for the later operational life of the operation of the information system is high. So let's discuss one by one the characteristics of these maintenance tasks. So first is the corrective maintenance. It diagnoses and corrects errors in an operational system. So responds to errors in various ways depending on the nature. So worst case situation is a system failure. Of course, you have to correct what happened. Why does the system as a system failure? And when the system is operational again, the maintenance team determines the cause, for example, of the system failure, analyzes the problem, and designs a permanent solution so that, for example, again, system failure will not occur anymore if this problem will occur again. So that is corrective maintenance. Next is we have the adaptive maintenance. So adds enhancements to an operational system and makes the system easier to use. For example, you're going to improve the user interface. So that is already an example of adaptive maintenance. The procedure for minor adaptive maintenance is similar to routine corrective maintenance. It can be more difficult than new systems development because the enhancements must work within the constraints of an existing system. So for adaptive maintenance, you always have to consider the constraints of an existing system for the enhancement. Next is we have perfective maintenance. It involves changing an operational system to make it more efficient, reliable, and maintainable. For example, you want the system to respond less in a time. So that is an example of a perfective maintenance. Then cost effective during the middle of the system's operational life. Programs that need a large number of maintenance changes usually are good candidates for re-engineering. Maybe you need to have again to develop a new system since conducting perfective maintenance will be costly. And then the more a program changes, the more likely it is to become inefficient and difficult to maintain. So instead of having perfective maintenance, you should already consider if there are many perfective maintenance that you are doing to the system, then it is maybe a high time for you to have a new system. And then last but not the least is we have the preventive maintenance. Requires analysis of areas where trouble is likely to occur. So we have this adage, prevention is better than cure. So IT department normally initiates preventive maintenance, often results in increased user satisfaction, decreased downtime, and reduced TCO or total cost of ownership. So the sad thing for preventive maintenance sometimes does not receive the high priority that it deserves. So for maintenance management, so the maintenance team is composed of the system administrator, systems analysts, and programmers. And of course, we have these organizational issues such as code of ethics for maintenance team. So you have to make sure, since you are in the maintenance team, that you're really doing your work. It's not because, for example, you really intended to have this system an error so that you're going to be paid for every maintenance checks that you will have. So you should have a code of ethics since you are the maintenance team. Actually, in all areas, there should be a code of ethics, especially if you go for data, and then of course for the hardware. And then next is we have maintenance requests. So maintenance request involves a series of steps. So all work must be covered by a specific request. And then we have initial determination. So you must see if this is feasible, if the maintenance is difficult to handle, or is it really true, or is it really as I've said, feasible? Is this really will affect the operations of the system? And then then we also have for the maintenance request a systems review committee, and then we should have a scheduled for the task completion, and of course you have to notify the users who requested for maintenance if it is completed or it has already been implemented. Okay, for maintenance management, you also have to establish priorities for the maintenance requests. In many companies, systems review committee separates maintenance requests from new systems development requests. So since maintenance request is for the current operating system, while the new systems development request is for example, if they encountered a problem and then suggested for a new system, so it's a separate request. And then some IT managers believed that evaluating all projects together leads to the best possible decisions. And an objective for establishing priorities is to have a procedure that balances new development and necessary maintenance work, because the maintenance team is also composed of the systems analysts and the programmers, and the one who's going to develop the system are also the ones are included in the maintenance team. Okay, next is we have also the configuration management. As enterprise-wide information systems grow more complex, configuration management becomes critical. Of course, the information systems installed from one office to another, and it is enterprise-wide. You have to make sure that they're really integrated and their configuration is correct. It also helps to organize and handle documentation. And then we also have maintenance releases. It is a numbering pattern distinguishes the different releases. And then it reduces the documentation burden because, of course, if it is a higher number, meaning it is a later release than the previous one. And it can also come with service packs. So maintenance releases have something to do with also with the version control. So version control is archived and essential part of system documentation. So you have to have, if this is a beta release, alpha release, and then you should have a version so that they will know if it is a minor or a major change depending on the version number and the maintenance release number. Okay, next is we have baselines. So systems analysts use baselines as yardsticks to document features and performance during the system's development process. So we have three baselines. So we have the functional baseline, the allocated baseline, and the product baseline. For functional baseline it is the configuration of the system documented at the beginning of the project. So that is the functional baseline. Whereas allocated baseline documents the system at the end of the design phase and identifies any changes since the functional baseline. So allocated baseline is uh, the baseline at the end of the design phase, and it also identifies if there is any change between the functional baseline. And then last but not the least, we have the product baseline. It describes the system at the beginning of system operation. So next is we have system performance management. So for under system performance management is we have default management. The more complex the system, the more difficult it can be to analyze symptoms and isolate a cause, of course, because sometimes you thought that the underlying cause of this problem is is this one, but if you're going to analyze it, there is another problem that really that really causes that issue. And then the best strategy is to prevent problems by monitoring system performance and workload. So for a computer system, for example, for this illustration, for example, why is your random access memory is always full, but you haven't used any app? So that is an example of fault management. You're going to look as to why, what is the program loaded in your memory while you're not really doing anything. Okay, next is we have the performance and workload measurement. So we have this so-called benchmark testing. So benchmark testing, these are applications that are available in the market in which you can, for example, your computer, you want to benchmark it against for the new computer systems, and then you're going to view the performance of your computer against the data of the newer computer systems that are available. So that is an example of benchmark testing. And then we also have metrics. These are the performance. For example, loading of page must be at most 5 seconds or less. So that is already a metric. So an example of metric is the response time and bandwidth and throughput. For bandwidth, that's for example, your website, does it operates in kilobits per second, megabits per second, or gigabits per second? So these are examples of metrics. And then we also have this turnaround time. So turnaround time means if, for example, a user has a request for this data, and then how long it will be processed and will be given to that user. So that is already the turnaround time. How long will the data be processed or the request be granted? And then the IT department often measures response time, bandwidth, throughput, and turnaround time to evaluate system performance both before and after changes to the system or business information requirements. And then management uses current performance and workload data as input for the capacity planning process. Of course, for capacity planning process, you should know of the current performance and workload data so that you can estimate what does your system can and cannot do, the limitation and delimitation of your system. Okay, what is capacity planning? It is a what-if analysis. So, for example, we have this capacity planning analysis. So, if your data for processing time in seconds per website order is 22.5, so what if this is your processing time? So, it means your maximum web-based orders per day will be 3,840. So that is an example of a what-if analysis. So it needs detailed information. You cannot do capacity planning if you don't know, of course, the capacity of your information system, of what the information system can and cannot do. It also needs an accurate forecast of future business activities of the capacity planning, and it should develop contingency plan based on input from users and management. Okay, next is we have system maintenance tools. So many case tools include system evaluation and maintenance features. And in addition to these case tools, you can also use spreadsheet and presentation software to calculate trends, perform what-if analysis, and create attractive charts and graphs to display the results. So more like case tools, you can have a dashboard so that you can easily understand the trends, the what-if analysis in a of course not in a text, but of course by using visuals. Okay, next is we have system security. So for its overview, so security is a vital part of every computer system. So system security concept is we have the CIA triangle. So CIA stands for, C is for confidentiality, I is for integrity, and A is for availability. So these three, integrity, confidentiality, and availability, these are the boundaries of information. So information must be confidential, available, and it must have an integrity. So by means of this CIA triangle, you can create a security policy for your information bounded by confidentiality, integrity, and availability. So we also have risk management, of course. So absolute security is not a realistic goal. For example, for a database, for you to really secure your database, no one should access it, even the computers physically. So that is already the absolute security, but it is not a realistic goal. How are you going to use your database if no one is going to access it? So we have to have a risk identification. Example is the exploits that is used by the hackers. And then risk assessment, of course, is you have to assess the risk of what is the impact of this risk if it happens in the information system. And then we have this risk control, of course, avoidance. It's like prevention is better than cure, or mitigation. If if the risk occurs, how are you going to minimize the impact? And then transference is you're going to transfer to lessen again the impact of the risk, and acceptance of the risk that it is really actually happening. So for risk management, we have um, three steps. We have to identify the risk, assess the impact of the risk, and control the risk, and it is in cycle. Okay, next is we have attacker profiles and attacks. So an attack might be launched by a disgruntled employee inside the company, or a hacker who is 10,000 miles away using your network or internet connection. So attackers break into a system to cause damage, steal information, or gain recognition, among other reasons. Some attackers, especially hackers, why are, for example, in the news, hackers hacked a government website. It's not really to steal the information or vandalizing the websites. It's just making fun of them that their security is very poor. So that is sometimes the purpose of the hackers. They have nothing to do. And then next is we have security levels. We have physical, network, application, file, procedural, and user. So must consider six separate but interrelated levels. First is we have the physical security. First level of security concerns the physical environment. So physical access to a computer represents an entry point into the system. It must be controlled and protected. So what are the ways to control the physical contact or access to a computer? So we have this operation center security by using we have using biometrics, your eyes or your fingerprint. And then for servers and desktop computers, of course, must be guarded in a room, and then there must be a person who will be in charge, who will be monitoring. And then for notebook computers, is sometimes there is a lock, or there you cannot, for example, since a notebook computer it is portable. For example, in your company, security officials will check. For example, are you allowed to take notebook computers of the company at home? Do you have any permission? So that is an example of physical security level. So for network security, so it has something to do with the network and also the network interface. So for network security, you have to use encryption. And then we also have the encrypting network traffic. So for security level, so we have an example here. So this person encrypted the message with a public key, and then it will be sent to the intended user. The intended user, for him or her to read the message, he or she must decrypt with the matching private key. So if he or she does not have a matching private key, so it means the message is not for him or her. And another issues for network security is for wireless networks. So that's why they have password for wireless networks, and of course private networks. So only authorized devices can access the network. And also we have virtual private networks, ports and services, and use of firewalls. And then next is we have the application security. So for services, so services are application that monitors or listen to a particular port. So that is why for services, you have to have for example, for its port, it should be the appropriate data that must enter into that port. And then we also have this hardening. So the term hardening makes a system more secure by removing unnecessary accounts, services, and features. So for example, we have an accounting information system. Someone from the sales department has the access to the accounting information system. So to make the information system hard, you must remove the account of the sales because it is only intended for the accounting information system. Another example of hardening is using antivirus and anti-spyware software. And then, of course, we have application permissions. Are you allowed to use the application? And then input validation, you must have the correct data to input for the application. And then, of course, to prevent errors and issues of a software, needs to have patches and updates. And, of course, software logs for auditing if there will be an error for the application. And then next is we have file security. So permissions. So is this user allowed to read a file, write a file, execute a file, read a directory, or write a directory? So for file security, we have these user groups. For example, there is a user group for administration, administrators, and then user groups for guests. So these are examples for file security. So if you're a guest, so meaning you can only read a directory or read a file. You cannot write, execute, and write a directory since you are a guest. But if you are an administrator, you can do anything inside or you can do any changes from any files. Okay, next is we have user security. So user security, we have to prevent the privilege escalation attack. So meaning, that's why privilege escalation, you are acquiring data or information that is to be used to access data or the information. And then we have this identity management. So that's why, for example, if you're going to have an email, there is a secret question, a very personal question. For example, what is the name of your dog? So you're going to put your the name of your dog, and then for example, if you forgot your password or if someone will access, they will answer the email, for example, ask a personal question. So that is an example of identity management. Of course, we have password protection. So by means of masking your password, or for example, the password for the internet connection, for wireless internet connection in smartphones, instead that if you're going to share the password from one person to another, instead of typing it, you can share by using QR code, so that you can still share the password for example, for your friend, but that does not necessarily mean that your friend knows the actual password. And then we also have this social engineering. Social engineering is tricking someone to get the information. For example, in a chat, if you're very naive and then someone chatted you that this is your mother's friend, your mother is in the hospital, I need money to, for example, like that. If you're really are a person is very gullible and you will be fooled easily, so that is already an example of social engineering. Okay, we also have, aside from this discussion, we have user resistance. What is this user resistance? Sometimes, specifically senior managers, um, they are very resistant for security. Example, the manager is going out from the company, and then the security official will check their belongings, their bag, the inside of their bag. And then the manager will say, why are you going to do this? I'm the manager. So that's already an example of a user resistance that for security, for us, may it be you're a rank and file employee or a manager, you must follow the protocols for security just to make sure that not that nothing is wrong So that's why security officials will not be blamed because they're also doing their job. And then we also have these new technologies such as security tokens, such as, for example, your the for example, you're buying online, and then what if you are buying an online shopping, from online shopping, and then there is a time that for a longest time you did not access their site, and then when you're going to input your username and password, then since you registered your number, there will be a text message to your registered number that will give you the code that it will really identify that it is really you and it is not being hacked by another person. So that is already an example of new technologies for user security. And then procedural security, or the it is also called the operational security. So types of procedural security is we have the dumpster diving. So dumpster diving, um, persons or people who have interest in the company, they're looking, of course, that's why it's called dumpster diving. They're looking for data and information that is in your trash bin. Then they will look for financial data. So that's why, because of that, uh, companies uh, uses companies use paper shredders, so that any confidential data, even though it will be thrown outside or will be disposed, so no one can know the financial or confidential data. So that's why that is the solution, using paper shredding for dumpster divers. Okay, next is we have backup and disaster recovery. So of course, for backups, we should have a backup policy of what are the procedures that we're going to do for backup. And then for backup media, are you going to use a USB drive or a hard drive or a tape drive or DVD or CD? So it depends upon the company. And then they have this rotation schedule. For example, you have this media. This first backup media, you're going to back up it, and then for the next day, the second media, and so forth. And they will have a rotation of how are you going to back up your data. And then we also have this off-siting. So meaning, your backup data is located away from the main company or the main site, so that if any breach or any, for example, physical security issues will happen, the data from away from the main site is safe. For example, there is a flood or there is an earthquake, and this the offsite the place where the data is secured is not affected. So that is why it is really very important to have these offsites. And then what are the backup types? So we're going to discuss the backup types on the next slide. And then the retention periods. So how long you're going to archive your backup data? Is it be counting in years, or only days or weeks or months? So it depends upon your company's backup policy. So these are the types of backups. We have the full, differential, incremental, and continuous. For full, it backs up all the files. So what are the pros and cons? It is the slowest backup time and requires the most storage space. Rapid recovery because all files are restored in a single step. That is the uh, advantage, and disadvantage is lowest backup time. Typical frequency for full is monthly or weekly. And then differential, its characteristic only backs up files that are new or changed since the last full backup. So, advantage, faster than a full backup and requires less storage space. All data can be restored in just two steps by using the last full backup and the last differential backup. So, the typical frequency is weekly or daily. So next is we have the incremental backup. Only backs up files that are new or changed since the last backup of any kind. So fastest backup and requires the least storage space because it only saves files that have never been backed up. So that is the difference between differential backup. However, requires many restore steps, one for each incremental backup. So that is the disadvantage. And then the typical frequency for incremental backup is daily or more often. And then last but not the least is we have the continuous backup. So characteristic is real-time streaming method that records all system activity. So its disadvantage is it requires very expensive hardware, software, and network capacity. So, but the advantage is recovery is very fast because system can be restored to just before an interruption. So, typical frequency usually only used by large firms and network-based systems, of course, because this is as it said, it is very expensive. So, what are the business continuity issues? So, every disaster recovery plan must have a test plan. So, a test plan is like a simulation of an emergency and then analyzing what are the steps to be done, what are the improvements to be done if an actual disaster will occur. So, test plan is like, for example, earthquake drill. So, that is already an example of a test plan. And then business continuity plan, of course, by the word itself, what will the company do if ever there is a disruption in the business processes of the company? And then it also includes a hot site, meaning if there is a disruption in the business processes, there should have an alternate location where the business processes can continue its operation. And then hot site requires data replication because if there is a disruption in the main site, the hot site can continue the operations, and then it also requires data replication of from the main site. Okay, next is we have system obsolescence. At some point, every system becomes obsolete. So, obsolete, so meaning it will be, it's not, for example, for a system, if it is already a 5-year-old information system, it is already considered as obsolete, so it needs to be upgraded. So, systems operation and support continues until a replacement system is installed. At some point in a system's operational life, maintenance costs start to increase, users begin to ask for more features and capability, new systems requests are submitted, and the SDLC begins again. So, this is the points to remember that if the maintenance costs start to increase, users begin to ask for more features and capability, and new systems requests are submitted, then again, the cycle again will start for the systems development life cycle. So for future challenges and opportunities, what are the predictions? The highest priorities will be the safety and security of corporate operations, environmental concerns, and bottom line TCO. Gartner Incorporated is a leading IT consulting firm that is famous for forecasting industry trends. So that is their prediction. And then author Randall Strauss notes that the enormous amount of energy needed to drive cloud computing, including Google servers, has raised serious environmental concerns. So there is a new term for green technology, green servers. This is environment friendly servers. And then strategic planning for IT professionals. Working backwards from your long-term goals, you can develop intermediate milestones and begin to manage your career just as you would manage an IT project. So planning a career is not unlike planting a tree that takes several years to reach a certain height. For IT professionals, if you have the right credentials, you do not wait very long for promotion or for other greater career opportunities. So what are the IT credentials and certifications? So of course, credentials aside from your um, degree that you will acquire from the academic institution. So since of course we are in the IT industry, so because there are many software, hardware technologies that will always be on the lookout because there are many updates because of innovations in technology. So as IT professionals or would-be IT professionals, you should be responsible to yourselves to upgrade yourselves, your skills, in order for you to fit in the industry workforce. So aside from that, you should have certifications If it is free, grab it, grab the opportunity. If there's scholarship, grab it. So if it is paid and you really needed that badly, of course, you have to invest because certification is also an investment for yourself. That is so that's why certification, it really you're really a certified user for this, or you certified expert for this hardware or software technology. So in addition to Microsoft, many other IT industry leaders offer certifications, including the Cisco, the Novell, Oracle, and Sun Microsystems. So if you again, if you're really going to encounter a certification, if it is free, grab it. It's not just because it is required by your teacher, but if you're thinking proactively that it is also for you, that as early as you're still student and you have the opportunity to take a certification examination, then grab it, and then you can use it as a credential or as an additional credit for your portfolio for job hunting. And then aside from this credential, you should have critical thinking skills such as soft skills. So soft skills, you must search about the 21st century skills that are needed in the industry 4.0. So soft skills, this includes collaboration. So you should know how to work in teams, communication. You should be good in written and oral communication skills. So these are examples of soft skills. And then Certiport is an example of this company, and the educational testing service introduced the critical thinking certification exam. But I think it is based in the US and it is not for free. And then individual and team-based exercises can strengthen critical thinking skills. So it's not just very important that you have the right credentials, but you should have these soft skills, or what you call people skills. Because if you're the best programmer, but your attitude, or you do not know how to cooperate, how to work well with a team, is and then since companies nowadays and the setup is more of a collaborative or a team environment, it will be difficult for you. So you have to develop people skills or the soft skills aside from being an expert in this particular field. So, chapter summary. So, system support and security covers the entire period from the implementation of an information system until the system no longer is used. A systems analyst's primary involvement with an operational system is to manage and solve user support requests. Systems analysts need the same talents and abilities for maintenance work as they use when developing a new system. Security is a vital part of every computer system, and all information systems eventually become obsolete. An IT professional should have a strategic career plan that includes long-term goals and intermediate milestones. An important element of a personal strategic plan is the acquisition of IT credentials and certifications that document specific knowledge and skills. So we are already finished with chapter 12. And this is also the last chapter of the Systems Analysis and Design lecture series. So I hope that you have learned something from this lecture series. And if you do have any questions and concerns, please free to comment below. And I hope that you're going to still support my YouTube channel. So don't forget to subscribe. And see you in my other lecture series. So again, thank you very much and good day.